Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this course, we see about the embedded system and IOMT subject topic for biomedical engineers. The topic is a application software. So let us define the application software. What is application software? So application software is a embedded system. It's referred to a specific program and function designed to execute particular task or process required by the end user or the system itself. So application software means it is a specific program and function designed to execute a particular task. So it is unlike a system software which manage hardware resources and provide a platform for application software. Application software perform the user oriented task. Next, let us see the types of a application software. So first one is a real-time operating system. So it provides a multitasking capabilities with predictable timing for executing tasks. Let us consider the examples. FreeRTOS and VxWorks and QNX. These are the real-time operating system. Next, firmware. It is a specialized software that is embedded directly into hardware, providing control and functionality for specific hardware components. Examples of the firmware is a device drivers and bootloaders. And next to type is a utility programs. So support the functioning and maintenance of the system such as a diagnostic and system monitoring tools. Examples for utility programs are diagnostic tools, configurations, utilities. Now let us consider the design consideration of a application software. So real-time constraints. So it is application software must meet timing constraints, ensuring that critical tasks are executed within a specific time limits. Next consideration is a resource constraints. Embedded systems often have a limited memory and processing power, so application software must be optimized for efficient use of these resources. The next one is a reliability and robustness. So the software must be reliable, handling unexpected conditions gracefully and maintaining system stability. Now let us consider as a development process of the application software. So requirement analysis, what are the requirements we need that? So understanding the needs and requirements of the application to define what the software must accomplish. Next, design, creating detailed designs of the software architecture including models, interfaces and interactions. Next, implementation. So coding the software based on the design applications, often using high level programming language like C or C++. Next one is a testing. So rigorous testing to ensure this software meets all requirements, performs correctly and it's free of bugs. Next one is a deployment. So installing the software on the target hardware and configuring it is for operation. These are the application software development process. So in the development process, we have a requirement analysis and next design, then implementation and then testing, and after that finally we want to deploy the our software in the hardware. Now tools and environments. What are the tools we needed for implementing the application software? First one is a integrated development environment. So it will be provide a comprehensive environment for coding, debugging and testing application software. For example, IDE examples are Kale, Microvisions and MPLab X IDE and debuggers. Next tool is a debuggers. So these tools used to identify and fix issues in the software. For example, debuggers examples are GDP, that is a GNU debugger, GTAC debuggers. Now let us consider the examples of application software. So in industrial automation system, It controls system for manufacturing process requiring real-time control and monitoring. When we see about the application software in medical devices, software controlling diagnostic machines or therapeutic device adhering to stringent safety and performance standard. And next one is a consumer electronics, uh, firmware and applications for devices such as smart watches, home automation system and digital cameras. And now let us see the system software. So in previously we discussed that is the application software. Now let us see the system software. So first one is a definition. So system software manage and control the hardware component of a embedded system. It will be providing a foundation for running application software. So it also include operating system, device drivers and utilities essential for system operation. What are the components of system software? First one is a operating system. So operating system provide a platform for running application software and managing hardware resources. For example, embedded Linux, Windows embedded, these are the operating system. And next component is a device drivers. So device driver is specialized program that facilitate communication between the operating system and hardware devices. For example, drivers for sensor, actuators and communication interfaces. And next component of a system software is a bootloader. So bootloader initial code that runs when the embedded system is powered on, responsible for loading the operating system. Example for bootloader U-boot and dash U-boot. Next let us see the key function of a system software, that is a hardware abstraction. So hardware abstraction means it abstracts hardware details from application software, allowing application to interact with the hardware using a standardized interface. And next one is a resource management, manages system resources such as a CPU, memory and input output devices, ensuring efficient utilization and multitasking. And next one is a task scheduling, manages the execution of multiple tasks, ensuring that real-time constraints and priorities are met. Let us see the design consideration of our system software. In the design consideration, we think about the performance, stability and security. So I hope that all of you understood about the system software and also application software. Thank you.